Okay, so in this video we're going to discuss standard form, and it is the form that you can use to write a linear equation. So far we discussed slope-intercept form, point-slope form, and this is the third form. So according to our textbook, the definition is that it's a form, so it looks like ax plus by equals c, and a, b, and c just have to be real numbers. What I'm going to do is I'm actually going to highlight that to show you. Right, so the definition according to our textbook is that the a, b, and c are real numbers, and a and b are not both zero. It doesn't really say anything about a, b, and c being fractions or integers, whether a has to be positive or negative, so our book uses a fairly loose definition of standard form. We discussed in class how different books have different definitions of what standard form looks like, so I found a different textbook that has a very specific definition, and that's the definition that we're going to use. So it is also, it also looks like ax plus by equals c, but the difference is the requirement for a, b, and c. So I'm going to highlight this as well. So in this one, a has to be positive, a and b have to be not zero, a, b, and c are integers, so that's the third requirement, and they're integers whose greatest common factor is 1. And this is just a different way of saying that if you can simplify the equation in standard form, that you should simplify it. So for example, what that means is that you would not want to write, so if you get an answer 2x plus 4y is equal to 6, right? So the greatest common factor of 2, 4, and 6 is not 1, it's actually 2. So this is not actually simple form, standard form, until you simplify this. So once you simplify this, now it's going to be the real standard form, right? So you have a is positive, check. A and b are not zero, so check. A, b, and c are integers, so they are integers, so that's good. And the greatest common factor of those integers is 1, which is what we have. So this is again the definition that we're going to use in our class. Okay, so the first skill that we're going to talk about is going to be recognizing equivalent equations, and is in any form. And basically, to get the equivalent equations, you simply have to take an equation and either multiply it by the same number or divide it by the same number. Okay, so example number 1, write equivalent equations in standard form. So write two equations in standard form that are equivalent. So you have two options. You can either simplify your equations if you can, or make it more complicated. So I have 2, 6, and 4, which are all divisible by 2. So here's my original equation. And my first equivalent equation is going to be reduced by 2. So I'm going to divide everything by 2. So 2x divided by 2 is x, 6y divided by 2 is 3y, and 4 divided by 2 is 2. So notice that I did divide by 2 every single part of the equation. So then I can't really make it more simpler because I already simplified it, so then I can make it more complex. I could double everything, right? So I could get 4x minus 12y is equal to 8. So what is important for you to realize is that these are three different ways of writing the same exact equation. If you were to graph this equation, it would look exactly the same. So these are just different ways of writing it. So some of them are simplified, some of them are not simplified, but they all represent exactly the same line if you were to graph them. Okay, so if you can simplify, do so. If not, you can also make it more complicated to get more equivalent form. And this is something that could be done with any form. So I can also give you a slope-intercept form and ask you to give me an equivalent equation. And you can simply multiply everything by 3. Right? And it's exactly the same equation. I just multiplied everything by 3, so it is no longer in slope-intercept form, but it's an equation that's equivalent to the first one. So the equivalent equations can be used in any form, not just standard form. Okay, so now it is your turn to try an example, and if you can't read this, this is actually a y here. So it's x minus y equals 3, and you asked to write two equations in standard form. So pause the video and do the you try example. Alright, and we're back. And our skill number 16 is going to be writing an equation in standard form given a graph. So the first thing that we want to do from the graph is find the slope. And what I need you guys to think about first is, looking at the diagram, I want you to think about whether that slope should be positive or negative. So that should be your first thought. I'm going down, so my slope is negative. So don't forget the negative. Okay. And then I want to know how to find it. So it is going to be rise over run. And I'm going to use my graph here. So I went down 3. And then I went over 1. So my slope is going to be negative 3 over 1, which is negative 3, and it is negative just like I suspected, so that's great. Okay. Notice that it does say write an equation in standard form, so you will have to convert it. You don't start with standard form, you get your equation into standard form. So what I'm going to do is I'm going to use point slope form, and I'm going to use this point here because it's 1, 1, and they're both positive. So I'm going to change the color, and we're going to do the following. So I'm using point slope from here. Remember that you can start with any form, you just have to get it into standard form at the end. So y minus 1 is equal to negative 3 times x minus 1. And I'm going to distribute the negative 3. So I get y minus 1 is equal to negative 3x plus 3. And in standard form, your x's and y's are on the left side while your numbers are on the right hand side. So what I need to do is add 1 to move the number over. And I'm going to extend this. And I get y is equal to negative 3x plus 4. And I don't want to have x's on the right hand side, so I need to move them over to the left. So I'm going to add 3x here. And this is y plus 3x. Now in standard form, we always want to write x's first, so I'm going to write 3x first, and then I'm going to add the y, and then it's going to be equal to 4. So just double check. Your a is positive, and 3, 1, and 4 are integers, and you cannot simplify this equation. So this is going to be your actual answer here. Now what I want you guys to do is use some extra time, if you get extra time on the quiz, to check your answers, to actually check them. So the best way to check would be to substitute one of the points into the equation to see if it actually works out. So what I'm actually going to do, I'm going to use 2, negative 2, because I did not use it in my equation. So that's going to be like actually a better way to check because I didn't use it yet. So I'm going to substitute 2 for x. I'm going to substitute negative 2 for y. And I want to know, is my answer going to come out to be 4? If it doesn't come out to be 4, that means I messed up somewhere in the way. And it looks great. I get 4 equals 4. So I know 100% that I got the right answer. And you can feel confident that you will get 100% on that question on the quiz. So get in the habit of checking your answers if you can. Okay, so now this is your turn to try one, and what you need to do is write an equation in standard form of a line passing through these 2 points. So pause the video and see if you can do this on your own. Okay, so this is a very quick example that is not in our textbook, so I just wanted to go over. And the skill 17 is writing equations of vertical and horizontal lines given 2 points. And this is something we've been doing a lot during warm-up, so it's really going to be just a reminder. If you notice that the x's or the y's are both the same, then it's a special line. It's either vertical or horizontal. And what you want to concentrate on is going to be on what is actually the same. So my first question, my x coordinates are the same, and in my second question, my y coordinates are the same. So there's actually no work involved in this, and all you have to do is tell me that this equation is x equals 1. This is going to be the only way that both x's come out to be 1. And in the second example, my y's are both 3's, and the only way that's going to happen is if my equation is y equals 3. Now notice that I didn't have to find a slope, I didn't have to do any work, I just had to think about what kind of answer I should get and write this down. So it doesn't take long to do this question, however, it does require thinking, so get in the habit of looking for unusual things, such that x is being the same or y is being the same. Okay, my next example is for skill number 18, which is writing equations of vertical and horizontal lines given a graph. So here, I need you have to know some things, because otherwise you're not going to be able to figure it out. You need to know that a vertical line has an equation of x equals a number, and a horizontal line has an equation of y equals a number. And then it's just a matter of looking at the right thing. So for the blue line, it is a horizontal line, so I know the equation is going to be y equals, and all you have to do here is look at the y coordinate, right? So if the y coordinate is -4, that's the y equals. So that's your blue line, y equals -4. My red line is a vertical line, so I know it's going to be x equals, and in order to know what the x is, you just have to look at the x coordinate here. So it's x equals 4. So again, very similar to the skill before, it doesn't require a lot of work, but you do have to know that a vertical line has an equation of x equals, and the horizontal line has an equation of y equals. Okay, so now it's your turn. Pause the video and see if you can get these questions correct. And that's it. That's the end of our video for section 5.4.